ඔය පහළ තියෙන වගුව ලිව්වද මීට කලින් අපි? ලියන්නේ නැති. The write down topic: acidic, basic, and amphoteric nature of oxides. Acidic, basic, and amphoteric nature of oxides. බෝඩ් එක චුට්ටක් බලන්න. ලියන්න එපා ඊට කලින් බලන්න ඔයාලටම තමයි පුරවන්න වෙන්නේ. ඒ හින්දා මේක කියන මේ පුරවන විදිය බලාගත්තේ නැත්නම් ඔයාලට පුරව ගන්න බැරි වෙයි. හරි. දැන් අපි මේ කතා කරන්න යන්නේ ඔක්සයිඩ්ස් ගැන. කවුරු ගැනද පුතේ? ඔක්සයිඩ් ගැන. ඒ කියන්නේ ඔක්සිජන් එක්ක බොන්ඩ් වෙච්ච ඔක්සිජන් එක්ක සම්බන්ධ වෙච්ච ඕනම කෙමිකල් එකකට අපි කියනවා මොකද්ද? What is an oxide? Any element that combined with oxygen, no? So what we are going to find? Nature of oxide. Which nature? Acidic or basic or amphoteric nature? You know acidic and basic means. You have heard this word before. But think about amphoteric. Have you heard something called amphoteric before? No. Why? Listen first. You don't need right now, no? No ruler, no. You don't need anything now, right? Acidic and basic words are familiar for you, but you feel like amphoteric is somewhat differ, but it is not differ. You have heard someone called amphibians, no? Who are amphibians? Animals who can live in water and land both. So this amphoteric nature is also similar meaning which acidic and basic between properties, both acidic and basic properties. Understood? Amphoteric mean it shows both acidic and basic, right? Something like middle, some features are in the acidic part and some features are in the basic part, right? Understood? So amphibians and amphoteric are somewhat similar, no? Not similar. Amphibians are animals, right? But amphibians, what is the specialty of amphibians? They can live in water and land. So what are the specialty of amphoteric? They have acidic and basic both properties. Understood? Right. So we are going to write some oxides here. Sodium and here you can see, right? Elements in the period tree. What are the elements in the period tree? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon also in the period tree, but we don't write argon because argon is a noble gas. It do not make any bond, right? Sodium when combined with oxygen, what is the valency of sodium? Sodium, valency of sodium is equal to 1. Valency of oxygen is equal to 2. So everywhere valency of oxygen is 2, 2, 2, 2, 2 and here also 2. Right? You know the meaning of valency, no? Valency, I have taught you before. In your notes you can remember we did a part called chemical formula. We wrote chemical formula. Don't remember? We wrote chemical formula, something called chemical formula, sodium chloride, magnesium sulfate. We wrote the names and the what is the equation, chemical formula for this. So like that, here also we are going to build the chemical formula for sodium bonded with oxygen. We call it as sodium oxide, right? When sodium bonded with oxygen, we call it as what? Sodium oxide. So valency of sodium is 1, oxygen is 2. When you write formula of sodium oxide, you can directly write sodium and oxygen here. Then you can change the valencies. 2 comes here, Na2O. You don't need to write 1 here, right? Every time we don't need to write 1. No? When 1x is there, we don't write 1. We write only x. Something like that. We don't write here 1. Right? No need to write 1. Okay. Then what happens here? What is the valency of magnesium? 2. Don't you remember something like in the periodic table, right? I have taught you a pattern. 1, 2, 3, 4, 3, 2, 1. And again here 1, 2, 3, 4, 3, 2, 1 and 5, 6, 7. These are the valencies, right? So sodium is in the first line, first group. Group, you remember group, group. I have told you, no, Gu falls down. So likewise, in the first group, sodium is there. Sodium is in the first group. That's why the valency of sodium is 1. So magnesium is in the second group. That's why the valency of magnesium is equal to what? 2. Then what happens here? Magnesium oxide we can write directly, but if we can divide these two numbers by the same number, we have to divide that. So we can divide both numbers by 2. Then what happens? Both become 1. So Mg1 O1 comes here. Do we need to write 1? No. So you can write directly MgO, magnesium oxide. Mango, you can think like that, no problem. Na2O, here Na2O, K2O, no problem, because you are not writing the pronunciation in the paper, no? No, you don't write the how to pronounce in the paper, you don't write that. You can remember Na2O, K2O, mango, anything, no problem, but don't tell anyone that I don't something like that. I don't write something like that. That it is your choice. So, what is the valency of aluminium here? Valency of aluminium 3. What happens then? ALO valency should be changed. Then Al2O3 aluminium oxide. Right? Then silicon oxide is here. What is the valency of silicon? 4. Right? Can we divide these both numbers by the same number? Yes, we can divide by 2. Then what are the new valencies? Here 2, here 1. So you can write silicon oxide like this SiO. Then you can change the valencies. Then 1 comes here, 2 comes here. Right? Okay, SiO2, silicon oxide. Then what about phosphorus? What is the valency of phosphorus here? Huh? 5O3. Right? At many times, right, these valencies take 5 and 3 both. Sometimes 5, sometimes 3. Right? The syllabus of chemistry is consist mainly patterns. Chemistry is just patterns and special times without patterns. What is chemistry, Buddha? Patterns and there are special times without patterns. So this is a pattern of 1, 2, 3. There was a pattern. Then sometimes here 1, 2, 3, 4, 3, 2, 1. Here the pattern change. Right? This is special movement pattern change. So only these parts you have to remember carefully. Only these parts you have to remember carefully. Understood, Buddha? Right. So here what happened? Phosphorus takes valency of 5. Then PO here, you have to change the valencies. What happens? P2O5. Here, what happens? Sulfur and oxygen is here. Sulfur can take both 2 and 6. Most probably, the below valency is taken by these below elements. I mean group 3 elements. Right? Then what is the valency? 6. Then think about here, what is the valency? 7. But at every time chlorine is not 7. Most the times chlorine take 1. Many times chlorine take 1. But here special movement when making oxides, chlorine takes 7. That's why I told you chemistry is with the pattern and there are some special movements. It exceeds the pattern. You have to remember both of them. Making in memory Patterns is very easy, no? No? Patterns, it is very easy. Understanding patterns is very easy, no? Right. Okay. Then what happens is, oh wait, we can divide these two numbers by one number. What is that? 2. Divide both sides by 2. What happened then? Here 1, here 3. Then SO. What happens? SO3. SO3. So 3. So 3. So 3. Anything. Right. Here what happens, Buddha? Now you know what's going to happen here, no? No number, any number can divide these two numbers. Both are prime numbers, no? In the grade 6 you learn prime numbers, no? So both of these numbers cannot divide it by any number. By only that number you can divide. So chlorine oxide becomes Cl2O7. Right? Hands up if you understood how these oxides formula written by you. Can you understand how these formula are written? You can see the book can write it. I know that, right? It is easy, no? But in the examinations, in the exam, you are not allowed to look at the book. When they ask you to write the oxide of sodium, what you have to do? You have to write it by your own. They say only to write the oxide of sodium, oxide of magnesium, that's only. No? You have experience, no? In the papers, they ask you to write what is the oxide of something, magnesium, aluminium. Then they ask you to write what is the nature. Is it acidic, basic, amphoteric? Both have to do by your own. So you just have to remember only this thing. Aluminium is the guy here. Why? He is the amphoteric one. Who's that? Amphoteric one. Right? Aluminium oxide is amphoteric. Then you have to divide both sides into two parts. What you have to do? Divide both sides into parts. Here one side, here another side. You can divide this side two parts, one here, another one here. You can divide this part. There are four parts, no? Two here, another two here. Understood? Right? From this side, properties increase into this side and this side. You know that nature of oxides of metals are acidic or basic. Basic. In the previous week, I asked some questions regarding that part, no? You remember that? Oxides of metals are always. You cannot say that always basic, no? Mostly basic. Right? So, I told you that now the properties are increasing to this side. So you know that oxides of metal are basic, no? So this is light basic, right? This is highly basic. Or you can say that weak base here, but strong base here, anything. Understood or not? Just divide it into two parts. Increase in, no? This one weak, this one strong. Right? Then what happens here? These two are weak and these two become strong. These are weak acids. These are strong acids. It is a pattern. There is a pattern here. No? You can understand it. Any questions there? No, any questions? Tell me, Buddha, what is this table about? What is this table about? Acidic, basic and amphoteric nature of oxides, right? What is the period we take as example? Taken as example, third period. What are the elements there? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, right? Okay. Now you know how to write the oxide of sodium and oxide of magnesium by your own. Can you do that now? You can do that now. What is the pattern? Every time oxygen 2, 2, 2, 2, 2, right? In this occasion, right? In this occasion, very easy, no? 1, 2, 3, 4, 5, 6, 7. No? If the both numbers are divided by the same number, you can divide them by that number, then keep the remaining part, and when writing the formula, you have to change valencies. That's enough. Then what you have to check? You know that I told you to. You have to remember that aluminium is what? Amphoteric. Aluminium is amphoteric. Both sides become acidic and basic. By your memory, by recalling, you know that metals make always which oxide? Basic oxide. So you know that this side basic, this side acidic. The natures are increasing to this side and this side from amphoteric one. So this first one weak, next one strong. Here first two weak, next two strong. That's all. Now you can write, but don't talk. You can talk, but don't let me to hear that. No? Understood this part? Clearly? Nice. Write it. You are not allowed to look the board. Huh? You are grade 11 students, so take your book, think your own. Don't write textbook or the board note. Write it your own. Hello, brother. How are you? Feeling better? You came by the bicycle or on foot? Or eating something like this and flying? Ah. I know that how he comes to the class. That's why he is late. When someone come on foot, they can see the road, no? They have the path. But he is flying, no? He have to look many things, no? Nice guy. I told you that you are not allowed to talk here, right? You have to write the table. Otherwise, I will take you to the board and ask to write the table again. Can you do that by your own now? I know that you can. Do you like to do that? No. So don't talk here, right? Okay, right now. Don't look. Why are? No, no, no. You should remember the topic also, right? That's how you have to be clever like that.